The $1,000 bet with my brother. Can I get to expert on Codeforces before the end of May? This is my second ever competition. In my first competition, I achieved a rating score of 974. However, my current rating is only 442 because Codeforces has put a cap on the amount of rating you can get from a single competition. Can I get to 700 rating in this competition? Keep watching to find out. By the way, please like and subscribe if you enjoy this type of content. It helps out a ton. Enjoy the video. Alright, here's the first problem. In this problem, we are asked to find the number of ones in n binary strings, where a binary string is a string that consists of only the characters 1 and 0. Each of the binary strings are created from an original binary string s, but flipping one of its digits. The easiest way to solve this problem is by creating each of the n binary strings and iterating through each of its digits to find how many ones there are. Now, in contests, you should always implement the first solution that comes to mind and has a satisfactory time complexity. Instead, during this contest, I decided to find a method where you did not have to create all n binary strings. After about 3 minutes of thinking, I realized that such a solution can be found by finding the number of ones in the original string s and multiplying it by n, since each of the n binary strings are created from the original string. Then I realized that we had to sum some number s prime, where each of the digits of s prime are the opposite of the digits of s. So if one of the digits in s was 0, then that corresponding digit in s prime would be 1. The reason we need to add s prime to the sum is because I created s prime by taking each of the digits that were flipped in each one of the binary strings a1 through an to create s prime. However, this also means that we need to subtract one of the original number of ones in s. Therefore, the sum becomes n minus 1 times the number of ones in s plus the number of ones in s prime. Now, the number of ones in s prime can just be found by finding the number of digits in s, which is just n, and subtracting the number of ones in s. This finds the number of zeros in s, which are all ones in s prime. Keep watching to find the worst implementation start in coding competition history. If you haven't already, I'd really appreciate it if you could like and subscribe if you enjoyed this commentary. Thank you, and enjoy the rest of the video. Okay. And then there are multiple test cases here. Okay. This. Okay. And then just copy this. Okay. Oh. Swing to that. Whatever. Shoot. I have literally no idea what I'm doing, bro. Integer t 0. Dude, why am I coding so terribly today? I was only outputting 3 things. Okay, take a string s. Already solved it like way long ago. Don't know what we're doing, bro. Okay, so we should just iterate through s, right? And count number of characters. So actually, you can just take a sum. And you can just add that character. I'm not sure if that's adding the ASCII value. You try typecasting it. Because I can't change this. Okay. And just make sure that this one is correct. No, I don't know what I'm doing. Okay. Yeah. I don't think I should modify that. What is end characters? Yeah. I'm gonna create a new int, which is flipped s. And this is n minus s. So just create total here. Say total is n times sum. Forgot. Plus the flipped sum. Okay. And then we're supposed to see out the flipped sum. Constant compile error. Because that's just how good I am at coding. Oh, no, it's the first test case. Oh no, there's 2 lines. Each test case. Oh my god. Oh my god. Let me reorder this. Separate the input from the output. This goes first. And create int. semicolon. N was not this, yeah, should be fixed. We still have T. What? Wait. Why does it have dash? Oh, it's negative? Yeah, that's the ASCII value, 146. Typecasting's still not working. So how do I fix this? Oh yeah, I have static cast. No, I'm not sure this can work. Okay, so I just subtract the ASCII value. Oh, that actually works, yeah. That's not correct at all. Oh, I should have done a simple simulation. Man, oh man. I should have done a simple simulation. This should be 2 times 2. And then we add the flipped. This one's 5. That works. So, let me check what sum is. And backslash and clear for readability. 2 and 1. No, 2 is correct. So, should be n minus 1 times sum even. Oh, I'm so dumb. Okay. There we go. Now let's try this. Uh-oh. Oh no, I just didn't clear it. 50524 is correct. Okay, I just had to make sure my algorithm is correct. Don't want to lose 50 points. Okay. Why didn't I do this beforehand? What? So dumb. So yeah, essentially everything, all the strings are just the original string, except one digit is changed. That digit is equivalent to the flipped version. For example, if the original string is 1000, it would be 1000, or 1000. Now it would be 0000, 1100, 1010, and 1001. If we take, what I'm doing is I'm summing all of them on the diagonal, and then there should be a nice one, original ones. This is the same logic. I'm not. Just try to disprove it. I'm just gonna submit it. Just checking. 50524. Come on, come on. Damn it, 20 minutes? That's terrible. I'm gonna move on to the next problem. Synchron. Given a permutation p of length n that contains every integer 0 to n minus 1 in a strip of n cells. Dude, I cannot understand this problem. Given a permutation p that contains of length n that contains every integer in a strip of n cells. In a strip? I think I'm paint I saw the strip in the color. Paint the cells of this strip in the following way. 0, 2, 2, 4. What's pi? MEX of a sequence is defined as the first non-negative integer that does not appear in it. P1, that's the set. And the color, P2. Okay. Synchronal. Let's construct information pieces of the cells in the strip that are painted color X is maximized. Another mathy-like problem. I'm liking this. Helping solve 4 problems today. The first one contains a single integer. Okay. So this means the time complexity is n log n. Sorting? I'll put a t and then there's n and x. Number of cells in the color you want to maximize. I have a better boilerplate. Somewhere else. Dr. TC. New file. Yo, what happened? Why did it turn like all gray? Okay. Okay, that makes sense. Okay, this makes sense. What's the second? That's the color. Forgot. Strip in the color. MEX. Wait, so essentially 1032 is permutation 1. So the first this is just a permutation, right? Believe this means a subset. Yeah, that would make sense. We might paint. So is this the final result? Do believe so. Oh, this is interesting. Huh? Doesn't seem that hard. You just try to create it as early as possible. So there exist multiple such permutations. I'll put any of them. You just have to start with 0, 1. All the way up to x. All the way up to x minus 1. And then if we ever have x, then it stops, so we want. And then we go from n minus 1 down to, we just want the permutations, so let's do that. Doesn't feel like we need anything. I feel like it might have been a bad idea to do that for the first problem. Because, this might be some edge case that I miss. Hope not. And x, right? C. I feel like this should be really easy to just figure out arithmetically. This entire sequence has length n, and then this is just x, and this. So, but when he's coloring it, this will be colored x. And this will not be colored x. This will be colored n. So all these are colored x. And then here's x minus 1. And so, there's not x. And then it's colored x. It's just n minus x, right? Appears to be just n minus x. None of them are, no integers can be overflowing. Dude, I'm so dumb. I don't forget, you're supposed to be printing the permutation. Jesus Christ. Christies, mate. The confirmation, look. 2001303 200. Huh? Oh, we never get to it. X is not within the boundaries, okay. Same here. But we're just using a for loop, it shouldn't matter. Just put numbers until we reach x, and then we start putting numbers. We could just pass it. We're gonna be printing the n integers anyways. So, is there any situation where passing doesn't work? It's if x is n minus 1, then it's simply just be the last one that we print, and then x is in the middle. We're still printing n integers. And if x is at the beginning, we're still printing n. It doesn't matter, yeah. j is not equal to x, then let me print j. And print a white space. And then just to make sure x is greater than or equal to 0, and x is less than n. Otherwise, x never appears in the sequence. And then we end the line. It's again guaranteed compile error. Wow. Int I. Huh? Doesn't look like. Oh. Does this matter? If x is not in the sequence, then I'm gonna clear it. Yes, this is correct. Nice. 2, 3, 0. I know it doesn't line up, but that's just how this code works. Whoa. Ha. It's 3. Let's submit it. Submission. Um, 20 minutes again. Maybe faster than A, bro. Let's go. That's a bad idea. That's a bad idea. Let's go cherry bomb. Yeah. It's not looking very good for me. This is horrible. This is horrible. Such a bad performance. Okay. 2 integers arrays A and B of size n are complementary if there exists an integer x such that ai plus bi is x overall 1 is less than I is less than n. Complementary. Okay, that makes sense. For example, 214 is a sum to 5, right? Okay. Counter thinks everyone is interested in math. It's not. Everyone should be. gave cherry bomb to complementary integers a and b, is known that a and b contain non-negative integers, at most k. Unfortunately, cherry has lost some elements in b. Lost elements in b are denoted with -1. Help cherry bomb count the number of possible arrays b such that the number of possible arrays, not b, is a and b are complementary. Lost elements are replaced with non-negative integers no more than k. When will there ever be more than one? There's only one choice ever. Oh, they just have to be complementary. Oh. This is an interesting problem. Okay, to do this, let's see what the possibilities are. Yeah, if I read the input, I would have known. Sum of n over all this case does not exceed this, so sorting is allowed. Oh my god. I mean, that should only exist if they're all -1s. Because if they're not, then we already know what they sum up to. Like, this would be 0 and 3. Since we can do n log n, we can probably first pass through I don't know what the problem name was. Synchroma. Okay, so I can pass through I can first pass through I have to pass through both of them to make sure it's possible. See if they are all -1s. Then pass through both to see. So if B has an element that is not -1, then pass through both to see if B can add up to A. If yes, 1, no, 0. Then, if B is all -1s, then we need to figure out the maximum value of A. Looks like K here. they can max sum to k. They can max sum to k plus the smallest element of a. I'll probably write this down. Max sum to k plus. They're all positive integers. They're non-negative integers. K plus 1 min sum to min of a and min sum to max of a. So for example, in this example, that would mean minimum sum is 5. So it would be like first element can be range from 4, and the max is just what k is. K plus 1 here. So what's k? It's 10. So it's 4 to 10. That's 7. That looks correct. We're doing even worse. There's competition than the last one. But it's okay. My first problem was terrible. And the other one is called k. So here, okay, we can use binary search if we have to. Okay, but like if they're sets, then look time is very efficient. I'm just gonna use sets because I don't know what's gonna happen. Every set insertion is login. That's pretty cool. Dude, I always make this mistake. So now let's add all the elements to A. Let's just say int S1. Just do set dot insert S1. Dude, I am smart. Two variables. And then we do the same. Let's just copy paste this. Change this. Okay. First, let's go to the first pass through. I want to separate the input from everything else, so I'm not going to do it in here. Create a bool. That's clearly not allowed. A -1. So if j's minus is not equal to -1 actually, then we let bool all -1. Sorry, not even find this. It's now false. Oh. Okay, so if all -1 is equal to true, then now looking at this. So let's just say min A is, forgot to create B here. Let's just say min A is the smallest element in the set, which is A dot C in. And then at the R beacon, right? Okay, I forgot what we're doing. We're just printing that, yeah. Let's see. Oh, we still have to make sure that no, we don't. Oh, because we can decide what they are. Here's where K comes into play, yeah. It's, maximum possible is the K plus min, and the minimum possible is just max of A, because then we have that equal to 0. And we output max possible and a new line. Yes, not in the other case. Okay, so we cycle through and then we look at the first element that's not. Okay, so let's see. First element that's not, and B that's not -1, and then we realize that that's the sum. Why am I blinking right now? We just look at the next element. Oh shit. Okay. That's good. Yeah, we had to switch to vectors. Didn't realize that the elements could be the same. And then now we have to sort. That is correct, yes. This sorts in ascending by default. That's the first element. And the second element. Sorry, the last element. And because I'm Pythonic, I don't know how to do this. Would it be nice to sort B? No, can't. Have to keep it not sorted. I might just find the potential sum. Bro, it doesn't matter. I can iterate through it again. Let's do 2 for loops. And then the first one finds the first potential sum. So if b at j is not equal to why am I such a perfectionist? Don't have time for this. Don't even know how this works, bro. I'm not sure if I can initialize it like this. Not sure what goes in here. Stop being a perfectionist. It's all not needed for shift. Okay. It's dead. So yeah, if the sum of these two is ever not equal to the potential sum. Never not equal to the potential sum, then we know it's not. Now I'm worried. We can do this, right? Now I'm worried. I'm very worried. I have to keep another bool. Yeah, I have to keep a Boolean alive. Bool complementary. So we assume it's false. Then, no, we need to assume it's true. Then if this happens, then complementary is now false. Then the end of the loop after the loop finishes, we check if complementary. So if complementary is still true, then we output 1 and \n to clear. Boom. Guaranteed compile error. See? Wow. Missing template arguments before. What? What does that mean? Oh my god. I found available name. Shoot. I have to add one because it's inclusive. I failed these last three. I failed this one and this one. I'm a dumbass. Forgot. Make sure that K works for this. Yeah, we can sum up. How do we do this? This means that 2 minus 3. If this is I'll see if this is less than 0 or this is greater than K, then we do this again. Now I highly suspect. Oh my god. Can I like code today? How many test cases are we including? Oh, it printed 0 twice. every time we print 0, we have to make sure the complementary is true. That's the first time that we detected that the set cannot be built. There we go. I'm iterating through everything. It should be correct. It's more bashy. Man, this is the longest piece of code I've written in a competition. I'm right in the middle of all the newbies. It's horrible. 18,000 participants and bottom 50% me. Yeah. My 5 minutes and 11 minutes are a little sus. I think it makes sense to change much. Can you only add 1 flower? I have to be worried about overflow. of flowers in the garden and the number of flowers Igor wants to collect. Okay. Collects 5, 5, and 8, right? What? I flower among ones he collects must have a beauty of at least B of I. What do you mean by B of I? Oh. 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 Oh, this is a tough problem. So the first one that he collects have beauty of at least 4. So one option would just be place the flower right there. And run through it without adding any flowers and see if that changes anything. Ah, because skip so many there. You can only pick up 5 and 8. And then the 2. If you don't add anything. Does not necessarily pick up the same flowers. Not sure. Say put flower of beauty 4 before the first flower of beauty 5. Then we pick up the 4. Then once again, we miss a whole bunch. And then we pick up the 8 and the 2. Didn't help at all. Maybe there's some hint here. Unfortunately, cannot perform O of n squared. Oh, this is tough. This is tough. Do an m? No, definitely not. That would be too easy. Walk through a test case, try to get an understanding. Well, it must be one of the must be. If possible, K is some element of M. Sorry, B. Let's call B the set. Oh. That's a hint. So we can try like look at all the elements in M, and then we can see how many of them there are that are greater than or equal to this. Like we can sort this. So first we got 6, there's only 1, so we have to have a 6. And then we try something with 6. Sort M, look at, go backwards, maybe take a set of M, and then we just see if and I think if they're multiple, we have binary search as well, right? If there are multiple times where there's too many M that don't work, then it's definitely impossible. But there's still probably a lot of cases like here, where every time it seems like it's possible, but it's just not. This problem is hard, man. I'll see here, we just try 7. 7. But where do we try the 7? This is dynamic programming, but I don't know any dynamic programming. Oh no. It's just an algorithm. So, but I have to be smart enough to come up with an algorithm. And I'm not. I don't know if I can do that. What do I know about dynamic programming? It's like little subsets, right? Can we create some type of a subset such that that subset can gain something from that subset? Well. Okay, so yeah, we can pass through first to see if it works. But how am I supposed to get all the possible edge cases? How in the world? How am I supposed to detect that this doesn't work? I was supposed to know like what I'm supposed to add to try to make this work. Like it was 5, 1, 2, 3, 4. Then actually, what do is out of 5? I don't know how to do this. I'm gonna skip this. Yeah, this is embarrassing. Absolutely embarrassing. Wait, this is my rating for 967. That is sad. It's very sad. Wolf has found and she with tastiness values. Permutation. Binary search in P to find she with tastiness K, but P may not necessarily be sorted. Successive binary search on the range LR for K is represented as f of LR K, which is defined as follows. If L is greater than R, then the range L to R. Why are prompts so hard to understand? Sting of LR and K. Search begins. Calendar may choose a non-negative integer D, and this is where all may. No, this is just typical binary search. System 3 integers L, R, and K. Before the search begins, Kelvin choose non-numerals. D and D indices. What do you mean P of I? Okay. Not K. R. Then this. I think this first the length. This is so confusing. Can't even understand the problem. I'm just looking at explanations. Okay, yeah, it's an element. Is choosing some number of these such that they're not equal to K. I don't see what Caldener is doing. What is his role? Oh. Wow, this is difficult. Wow, this is difficult. So I feel like what this is hinting at is that every binary search, there are some key values. Animal 2 is the first key value here. So I'm looking for 4. And 1's the next key value. So I think maybe I want to swap 1 and 4. Oh, we're not searching the whole thing. Yes. Just searching 3 and 4. Yes, I believe there's some key values. But maybe I can do this one. Not gonna be easy. It's the floor, okay. So 5 is the first key value. So first of all, 6 is not in this set. I'm gonna make sure 6 is in this set. Make sure K is in the set. So then we do at least 2. Why can't I just swap with the first key value? Oh yeah, I'm stupid. Not allowed to swap it that. Yeah, because it's stupid binary search. God damn it. It is the index, right? Yes. We're still looking here. So it becomes 1 and 2. So we look at 1 first. You're never allowed to swap. Oh my god. It's not possible. Can't touch it. Alright, so this is the first key value, and this is the second key value. So you can swap like, yeah, because we have to touch both of these. You have to touch both these, and then replace them with something larger, so before. Nice. Essentially, the main idea is we're looking at all the key values, making sure that they are less than or greater than k based on what we need. If k is in the set, of course. Take a look at a bigger example here. So 4 is all the way back there. It's not possible? So 17 divided by 2, the floor of that, we're still looking at index 8. So we're looking at 3. You make sure it's greater than. Right, so we find the key values first. So the first key value is always. Just start coding a little bit here. Only 15 minutes. Only 15 minutes left. I'm not gonna make this mistake. Permutations suggest the use of sets. But no, because I have to access indexes. Some int call sheeps. Let me find the index. Right. Ooh. So it should start at L minus 1. 0 base index. We are no longer doing 0 based indexing. So if sheeps this could be problematic. Make sure we never access that 0 element. Save K index. Go to K index. You can just break. Okay, now we need to find key values. We'll find which chord, like for example, this is hard. Please, bro. Not sure to find the key values. Do we have to? I think we might have to implement binary search by ourselves. Figure this out recursively. So first key value is the first key value is the floor of the floor of no floor to integer. Okay. This floor I really have no idea what I'm doing right now. So we need to look inside that to see what we can do. Right, if k index is greater than I always check is equal to m, then obviously we just say d is equal to 0. But if it's greater than m, if it's greater than m and the actual actual value that is less than k, then that means that this is wrong. Would tell us to search lower, but wrong. So we would just have to swap this. Or it's the other way around. Plus equals 1 at the same time. Oh, damn.